Okay, today we get to talk about exponents. We're starting our algebra unit. I'm so excited because algebra is like one of my favorite things to do. So we're starting with exponents because you're going to see exponents quite a bit. We're going to start reviewing order of operations again coming up here pretty soon. Prime, composite numbers, prime factorization, all kinds of fun things before we get into our equations and expressions. So today is kind of an easy day because it's review. Most of us are familiar with exponents. We've done some practice with them before. So it'll go kind of quick. We'll do a Kahoot practice here in just a little bit. And then we'll do just independent practice for a grade. Okay, before we start, let's define what an exponent is. So an exponent is the number, oh dear, there we go. The number that indicates how many times the base is used as a factor. Okay, so when I look at this example over here with the n and then the 3, the n is called the base. That's my base number. The little number is called my exponent. The exponent again tells me how many times the number or the base is multiplied to itself. So it doesn't mean that if this is a 3, it doesn't mean 3 times 3. It means how many times is 3 multiplied by itself. The exponent tells me how many times I multiply 3 by itself. So what that would mean is that it is n times n times n again. Sometimes we call it raised to a certain power. So in this case, it might be called raised to the third power. But there's something special about 3 and 2 as exponents. If it's a little 2, we say what? Squared. If it's a little 3, we say what? Cubed. Those go hand in hand with area and volume. So you're going to see that again when we get to our measurement unit later on in the year. We start doing more with area and volume. All of our answers will be written in square units or cubic units. So we'll hear that again. But you can also say to the power of 3 or to the third power. Doesn't really matter. They're interchangeable. Okay, so we're going to fill in this table together. The first one is 4 to the first power. So the product is just 4, what it looks like, how I get the product. But the simplified product is my answer. So that is 4. 4 squared would be next, or 4 to the second power, or 4 to the power of 2. You can say them all 3 ways. What that looks like to get that product is really just doing 4 times 4, which is 16. Okay, 4 to the third power, or 4 cubed, is 4 times 4 times 4. So it's 16, the previous one, times 4 again, which, yes, is 64. And that's 4 to the fourth power, not 44. I just wrote it kind of big, and it's 256. The last one, 4 to the fifth power, I need to expand it out. Sometimes we call this expanded form. When we expand it all the way out, you have 4 times 4 times 4 times 4. Sometimes, guys, what you can do, hang on, listen for a second. Sometimes what you can do is you can say, okay, like for instance, 4 to the fourth power. I'm going to do 4 times 4 here. I know that's 16. This 4 times 4 is 16, and then just do 16 times 16. You can also say 16 times 4, and then that times 4, and then that times 4, again, depending on how much your exponent is, okay? But sometimes you can group them. I like to group. I don't know why. It's just what I do. So I tend to group things and then multiply those together instead of like multiplying by 4 and then another multiplying by 4 and so on. Okay, this last answer is 1024. Okay, the rest of this paper, I'm going to, on the left side, write the expressions with exponents. So I'm going to take my 1/3 times 1/3 times 1/3 times 1/3, and I'm going to write it like this, 1/3 to the power of 4, or to the fourth power. Why do you think I put 1/3 in parentheses?
Because we don't want.
I'm multiplying it, but what?
We don't want you to think it's 14 thirds.
Exactly. We don't want it to look like 14 thirds, okay? So if I don't have the parentheses and I write my 4 real close, like this, uh-oh, not like that. It might look like 14 thirds, and we don't want any confusion, okay? Okay. The next one, -3 times -3 times -3, and so on. We keep going. What would that look like? -3 to what?
5.
The power of 5. And then the last one is 7 to the power of 7. Okay, when it says find the value, it wants to actually know the value. So when it's -9 squared, we haven't learned multiplying integers yet, but a negative times a negative is a positive. So it would be -9 times another -9, which would be positive 81. This next one is crazy. So we are going to pretend like it says 1 to the 5th power, because otherwise it's going to take us forever to get through. It took us forever in the first class, and it's going to take us forever to get through this class. So we're going to just pretend like it's just 1 to the 5th power. So if it's 1 times 1 times 1 times 1, it's always going to be 1. And then the last one is 1/4 to the 5th power. I can use the chart above to help me. So remember, when you're multiplying, it kind of looks like this. 1/4 times 1/4. We just multiply straight across. So I know my numerator, no matter what, will stay a 1. It's the denominator that I'm having to multiply 4 times 4 times 4 again, times 4 again, times 4 again. So the bottom number is going to be
1,024.
yeah, 1,024.